Hey, another special thing we're going to show you today is how to factor polynomials in quadratic form. Now these polynomial expressions are not going to be quadratic to me, but we want you to start seeing it in sort of a similar way, similar kind of pattern or fashion that we introduced you to when we're studying quadratic polynomials. If you see this looks like a square where it has a nice square root. And I know it's a fourth degree term, but 16 has a square root of 4. X to the fourth has a square root of x squared. So we can think of this as the difference of two squares. 81 is a square as well. Here we have a square term, there we have a square term, and we have the difference between. So think of it in being able to be factored as you would a difference of two squares. The square root of 16x squared and the square root of the 81. Again, difference between them knows that one's plus, one's minus. Now we've got factored that far, but is it factored completely? Well, we have to look at this, and now we have, again, two squares. 2x, 3 being the square roots, but we don't have the difference between them. So the difference, or the sum of two squares, cannot be factored. So we leave that unfactored, can't be factored. But we look here, we've got two squares and the difference between. Again, we know we can factor that just like we did before. So we can factor that in how we've been taught. Square root of 4x squared and the square root of 9. Again, 1 plus, 1 minus. Here we have a term, sum of two squares can't be factored. Here we have a term, but there's no common factors in the 2x and the 3. No common factors in the 2x and the minus 3. Therefore, we know that we factored completely. Here's another example that if I didn't show you, it'd be a little confusing. Here we have a trinomial, but again, the first thing that I want you to look in all these problems, all these examples, of being able to factor out common terms. Look for that. Notice that all these coefficients are positive, so I can factor out a 2, and then I've got p to the second, I've got two p's there, and I got it. So we can factor out a common coefficient of 2, and then also a common factor of p to the second power out of each term. What would this be when I pull out or factor out a 2 and a p squared? Well, it's going to be p to the 6th power. P squared times p to the 6th is p to the 8th. You add the exponents with that power rule, right? So now what would this be? Well, 10 divided by 2 is 5, and p, we've just got 3 of those left, and then 12 divided by 2 is 6, and then we've taken all the p's out of that, so that's left. But that's a trinomial now. We factored common terms out. Now I'm left with a trinomial that I need to be able to recognize. It is a trinomial that can be factored the way we taught you back in the quadratic terms. Again, I know this isn't a quadratic, but you can think of this as being able to be factored into p to the 3rd power times p to the 3rd power, and then two things that multiply to 6 and add to 5. Two numbers that multiply to 6 and add to 5, that's going to be 3 and 2. So if I put a positive 3 and a positive 2, and then check my outer inner of that FOIL, I'm going to get 2p to the 3rd, and then 3p to the 3rd. Indeed, that does add to the 5p to the 3rd term I have in the middle, so I factored that correctly. Is it factored completely? Here I have a factor, it's just a monomial. Here I have a binomial, but can it be factored? Here I have a cube, the sum of 2, but is this a cube? Yeah, but is 3? No. But you need to start looking for that, seeing if you could factor it another time. Again, the sum of two things, one is a cube, one isn't. Since it's not a pattern that we've been teaching you, this is factored completely. Factor polynomials in quadratic form. We are the Ask Academy.